Okay, this is notes 11.5, inscribed angles and polygons. So an inscribed angle is going to be like this angle D over here, where it's going to be an angle that's the vertex is on the circle, and then it's got 2 points that are on the circle as well, so it goes all the way across the circle and back. An intercepted arc is going to be the arc that gets made from that angle. And then the inscribed polygon is going to be a polygon that is inside and all of the points touch the circle. So down on the bottom of this page, that's an inscribed triangle because it's inside of this triangle and all of the vertices, all of the corners are touching the circle. So the measure of an inscribed angle is actually going to be half. If you think about it like a rubber band, if you have these 2 points holding onto that rubber band, and then you pull the rubber band back to the center, whatever angle you get here, as you pull it back even farther, is going to get smaller. It's actually going to be cut in half. So whatever this measure is, this measure right here is going to be half of that. So like right here, this arc is 90 degrees. That means the central angle right there would also be 90 degrees. But when you pull it back even farther, it gets smaller. So the measure for angle A would be 45. It's going to be half of that 90. Over here, 160 would be the angle at the center. So once you pull it back, that 160 gets cut in half. So the measure for angle E would be 80 degrees. On this one, it's already pulled back, so you have to be careful. This is going in reverse. If you relaxed to the center, that means that it would get wider than it was here. That means you're going to double it. And that means that the arc FH would be double 70, so it'd be 140 degrees. And then over here, same thing. This is pulled back. If you went to the center, then that angle would be even more than 180, so it'd be really big. It's going to be double 120, so that means that the arc K and P going the long way around would be 240 degrees. If you have a triangle that's inscribed and the hypotenuse is the diameter, so if you see that it goes through the center right there, this has to be a right triangle, that has to be a right angle. So the examples for that on the back side go like this. This triangle has the diameter as one of its sides. That means the X has to be a right angle right there. And if you already know that this angle is 35 and that angle is 90 and all triangles are 180, subtract the 180 minus 90 and minus 35, and you find out that Y has to be 55. For number 6, again, this diameter right down the center is one of the sides. That means the angle Y over here has to be a right angle. So you already know that Y has to be 90. And then these two angles have to be what's left over from the other 90 degrees. So if 2x equals 90, divide both sides by 2, and you get x is 45 when y was 90. Number 7, this is a diameter. That means that across is going to be the right angle. So we already know the y has to be 90. And then this angle has to be what's left over. So you can go 180 minus 90 and 42, or even easier, you can go 90 minus 42, and you can find x that way. 11.9 says that if a quadrilateral can be inscribed in a circle, then its opposite angles have to be supplementary, so they have to be 180 degrees. That means that angle A and angle C make 180 degrees, and B and D add up to another 180 degrees. So over here, you'd go x and 95 should make 180. Subtract 95. and you find x is 85, and then for y, you're going to do the same thing going this way. The y and the 100 should make 180. Subtract 100 on both sides. Y is 80. For number 9, x and this angle right here have to add up to 180. Subtract both sides. And then y and this angle have to make 180. Subtract 90 from both sides. You get y equals 90. Number 10, going across is still supplementary, so the x goes with the 50. And the y goes with the 80. And there's your answers.